Hello, this video is about linear interpolation. Please have a bit of paper and a pen. As you go through the video, pause at each stage and work it out for yourself. Okay, the example we're going to take is we want to find the square root of 2, that is the solutions to the equation x squared minus 2 equals 0. We know we can't find this exactly, so all we're doing is trying to find a best guess. And sometimes students ask, how many times do you do linear interpolation? The answer is, in the exam, you'll almost always be asked to do it only once. If you were doing it on a computer, to get a better approximation, you might do it lots of times. Don't do it lots of times by hand, or you will end up, when you're old, very bitter and twisted because you spent a lot of time when you're 16 or 17 doing pointless calculations. Just learn how to do it once. Okay, we're trying to find out the square root of 2. Where we've got to so far is we know it's somewhere between 1.4 and 1.5. So we can work it out for what x squared minus 2 is for 1.4, and it's minus 0.04. That's what it is for x equals 1.4. For 1.5, it's plus 0.25. So we draw a diagram of what that looks like. And now, if we were doing interval bisection, our next guess would just be exactly halfway between. It would be 1.45. What we do in in linear interpolation, we say, well, that's throwing away a bit of information we've got, because it looks to us like it's going to be closer to 1.4. 1.4 is not so far out as 1.5. And we assume, for the sake of the approximation, that the curve of this function is something like a straight line in this small neighbourhood. Obviously, we know it's a curve, it's not a straight line, but if you take a small enough bit of a smooth curve, it looks like a straight line, just as we know the Earth is round, but if you look at a small bit of it, it looks flat. If you look at a small bit of a smooth curve, it looks like a straight line. In that case, the answer would be here. We know it's not exactly a straight line, but that's going to be fairly close. How do we find out what that point is? Right, let's call this delta. Delta is simply how much we're going to move from 1.4 to find our next guess. And let's draw in another triangle. So, if we draw in that triangle, we have two similar triangles here. There's a small triangle here, and that's similar, which means it's the same shape, though not the same size. It has the same angles, but it's not the same size to the red one. The green triangle and the red triangle are similar. So if they're similar, we know the angles are the same. The other thing we know is that the corresponding sides have the same proportion. So this side divided by that side. Now what's that side? It's the distance between 1.4 and 1.5, so that's 0.1, is equal to this side, which is 0.04, divided by that side, which is 0.04 plus 0.25. Okay, that's a simple sum you can do on your calculator, and you will get to 3 decimal places. Delta is 0.014. All you have to do now is to say what your next guess is, which is to add your delta to your point there, is 1.4 plus 0.014, which is 1.414, which is actually pretty good approximation. And that's the end of your linear interpolation.